Today, we're looking up, seriously, to the skies, because there's a revolution happening right above our heads. We're talking about aerial robotics, the drones and autonomous aircraft that are becoming the sentinels of our world. So, let's get into it.
First off, I want to ask you something. Just think about this for a second. What if a robot could go anywhere? Not just on the ground, not just in the water, but up, over, and around literally any obstacle in its path. That absolute freedom, that's the whole promise of aerial robotics.
So, what exactly is an air-based robot? Well, at its heart, it's any robot designed to fly, to use the atmosphere to move in 3 dimensions. Think about that. Unlike a robot on wheels, these machines aren't stuck on the ground. They're a mix of aerodynamics, super smart control systems, and robotics all rolled into one, designed to master the air.
Now let's be real. When I say air-based robot, your brain probably jumps straight to drones. And you know what? You're right. Drones are definitely the most common example we see everywhere. So let's start there and meet the key players in our skies.
Okay, so when you're designing a drone, you hit this big fork in the road. On one side, you've got your multirotor drones, like the quadcopters you see all the time. Think of them as acrobatic helicopters. They can hover perfectly still, which is amazing for getting stable video or doing really precise work. Then on the other side, you have fixed-wing robots. These guys are basically mini airplanes. They can't hover, but they are way more energy efficient, so they're perfect for covering huge distances, like mapping a giant farm.
But what if you don't want to choose? What if you need both of those things? Well, that's where hybrids come in. These are super clever designs that try to give us the best of both worlds. They can take off and land straight up like a multirotor, but then transition to fly efficiently like a fixed-wing plane. Pretty neat, right?
So we know what they are, but how in the world do they stay so perfectly stable in the air? It seems almost like magic, but it's not. To get it, we've got to pop the hood and look at the brains behind the operation.
It all boils down to this constant, ridiculously fast feedback loop. The easiest way to think about it is like your own sense of balance. The drone's sensors, its gyroscopes, its GPS, its cameras, they're like your inner ear, always telling it where it is and which way is up. All that data gets zapped to the onboard controller, the brain, which processes it instantly and tells the motors what to do. We're talking thousands of tiny adjustments every single second. It's that constant cycle, sense, think, act, repeat, that lets them fly with such incredible control. All right, now that we get just how precise these things are, it's no wonder that their uses are just exploding. I mean, with that kind of mobility and control, it feels like there's a drone for pretty much everything these days.
Let's start with security. Drones are like these tireless eyes in the sky. They can monitor huge areas. Think borders, power plants, big industrial sites, and stream that information live to people on the ground. It's a total game changer for surveillance.
And in farming? Oh, it's a full-blown revolution. Drones can fly over hundreds of acres, way faster than a person ever could, and check on the health of every single plant. Then they can go back and apply fertilizer or pesticide with surgical precision, only where it's needed. That means bigger harvests and way less chemical waste.
And of course, there's the one we've all been hearing about, package delivery. Yeah, companies are racing to build drone fleets that can get you your stuff faster than ever. Just imagine a world where your delivery just flies right over traffic and shows up at your door in minutes, not hours.
And here's where this technology becomes truly life-saving. After a natural disaster, when every single second is critical, drones can be in the air almost immediately. They give first responders a bird's-eye view, help find survivors, and even drop off essential supplies to people who are completely cut off.
Scientists are having a field day with this stuff too. They're using aerial robots to see our planet in a whole new way, collecting data from the atmosphere, tracking wildlife without disturbing them, and monitoring things like deforestation in real time. It's a powerful tool for understanding our world.
And finally, come on, if you've watched a movie or a news report in the last few years, you've seen their handiwork. Drones have totally transformed filmmaking and journalism. They give us those epic, sweeping aerial shots that used to cost a fortune and be a huge pain to get. But okay, let's pump the brakes a little. Before our skies are filled with these things, there are some pretty big challenges to sort out. These are the hurdles that engineers and governments are working on as we speak. There are really 3 big ones. First up is energy. Battery life is still the biggest buzzkill, limiting how long these things can stay in the air. Second, the weather. Drones are pretty lightweight, so strong winds and heavy rain can be a real problem. And finally, rules. We've got to figure out the rules of the road for the sky so we don't have drones bumping into each other or, airplanes. When you step back and look at the big picture, it's clear that air-based robots are a genuinely transformative technology. That ability to move freely in 3 dimensions, it just opens up a world of possibilities that honestly felt like science fiction just a little while ago. They're a true cornerstone of modern robotics.
And that really leaves us with one last massive question to chew on. We see what they can do now, but what happens when these challenges get solved? As these Sentinels start to fill our skies for real, how are they going to reshape our world? That's a future that's built right now, right over our heads.